Hi, my name is Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is probably the simplest audio effect you can think of. It's just a gain knob that changes the volume of your sound. And yet, it's interesting, though it's just probably one line of code, it's interesting to talk about a gain knob because it allows us to first understand how to change the volume on a wave, on sound, but also because it allows us to talk about the translation, the correspondence between amplitude and dB, decibels, which is a measurement of how loud the sound is, the volume of the sound. And we will talk about the translation between amplitude and dB and then back, which is super simple, but it's kind of obscure. It took me a while to understand why and how it really works. The formula is super simple, but the idea behind it's not so simple. So it took me a while to figure this out, and I wanted to share this with you. Okay, so let's get started here in Reaper. I'm going to start by first doing the thing that we always do. We mute, because we don't know if the effect that we are writing is going to produce any loud noises. So I'm muting the master channel. This way I'm sure that I will not blow the speakers. So let's create a new effect, and it will be a JS effect. Okay, so right click, create new effect. I'll put my name here and then my name, and this will be again JS effects. When you create a new effect, Reaper puts some code in place for you, and the code that it puts in place is a gain knob. So it's kind of cheating to look at this, okay? And there is some weird formula going on here. That's what we are going to talk about, but I don't want to cheat. So I'm getting rid of this code as the first thing. So what we want is exactly that plugin that has one slider, and it will change the volume of the incoming audio. The trick is really the unit of measurement of that slider. But let's start with the simple thing, okay? So I want to put this here on the side just so you can see here. You can see here the volume of the sound I'm producing with my voice. The idea is that we are going to be able to change this volume, right? And as you can see, in fact, here's another way to put this, and it will make it clear. Before, we created an oscilloscope. So if you don't know what this is about, then check out the other video on this channel in which we created an oscilloscope. It still has some bugs, but it works fine most of the time. And also, if you have no idea about how to create plugins in Reaper, what JS Effects is all about, then you should check the first video on this series in which we created a bit crusher. In that one, I explain the whole process and everything that's going on. Okay, so here we have the... I need to enable this so that you can actually see the waveform, so that it's going through the plugins. So now you can see this waveform, and when I speak quietly, you can see that the waveform is more narrow. And when I speak loudly, the waveform is more broad. It goes up and down more. And that's probably an intuition you already have from having worked in digital audio workstations or having used any app that shows audio with waveforms like this. Waveforms that go more up and down sound louder. And in this graph, right here in the middle, we have 0. On the top, we have 1. And on the bottom, we have -1, because every sample of audio is represented with a number between -1 and 1. So the idea of this gain knob is that it will change this number between -1 and 1 to make it closer to 0, therefore making the sound quieter, or move further away from 0 and closer to -1 and 1 so that it is louder. So let's start by writing some code in the sample part of the code, and this code block is executed for every sample that comes in. So we will start by saying sample 0, and that's the sample on the left side. is equal to, or actually I can write it like this. What I want to do is to multiply sample 0 by some number, for instance 0.5. But another way of writing this is, and that's even shorter, like so. Okay, so now all the samples that are coming on the left side are quieter. But you can see, you can already see the effect of this. When I turn this off, the waveform is a bit thicker than when I turned it on. So the effect that this has is already to change the volume, change the gain. So what we are doing is just multiplying by a constant the effect that that has. Suppose that the sample is like, I don't know, 0.75. And you multiply by 0.5, the number is smaller, so it's closer to 0. Same with minus 0.75. So if you have something below here, below this middle line, then it will be something like minus 0.75. And we multiply that by 0.5, you end up with a number that is closer to 0. It is further away from minus 1. So just by multiplying by a constant, you are changing the volume. Excellent. So that's how you change the volume. And you can do the same with the sample 1, and that's the sample on the right channel. So now you have the volume, this effect is affecting the volume on both sides of a stereo signal. In fact, there is no reason why we need to keep ourselves to just two channels. In fact, that's something that I think many audio effects do, but I see no reason why. Especially these simple audio effects like this, they are so simple that you could make them multi-channel. In fact, I'm curious, so I'm going to just create a new JS effect, and I'm going to call this remove me JS effect, just because I want to see the default that Reaper puts in place. And yes, the default is just treating sample 0 and 1. So this default is just stereo. There's no reason we need to keep this stereo. We could make it multi-channel very easily just by saying, I want to loop through all the channels that are in this track and change them all accordingly. And I think that's nice, first because it supports multi-channel, but also because it gives me a bad vibe when you have repeated code like this. And there are many effects in which this happens, and it just annoys me. So win-win for me. It will be multi-channel, and we won't have repeated code like that. We just need a loop, right? We just need to loop through all the channels, and there is a variable number of channels that comes with the JS effect. It's given by Reaper. We didn't define this variable. And somewhere in here, there will be the definition of that. Yes. So in this case, this is stereo. So we have just the number 2. But if we had more tracks, then this number would increase. In fact, why don't I just show you how that works? If I had 6 channels instead, now the number of channels is 6. Fair enough. But I'll keep this as stereo because I am using the microphone that is recording in stereo. Okay, so let's loop through every channel and change all the channels accordingly. Let's start with a variable that starts with -1 and then loops. And we saw the loop construct in the other video in which we built the oscilloscope. The idea is super simple. It is, well, let me organize the windows real quick. I'll put the window that is the oscilloscope right here, and then our code will be here. Okay, so then the loop construct, it takes the number of the number of times you want to go through the loop, and that's the number of channels in our case. And then it takes a block of code, and this block of code is going to start with the increment of the channel. And I like how this reads all in one line, and you can see the loop management in one place. And I think that is a convenient way of writing it. And sometimes the line ends up being too long, but it's another story. I like keeping it like this. It's as if you had a for loop in C or in many other languages. You keep, as long as it's short enough, you keep all the parts of the for loop in one line. So now we have this variable channel, and we can access the sample in that channel. and multiply it by some constant. So the work we are doing here is similar to the work we were doing here. In fact, we could have written this like so. That's equivalent. But when you don't have explicit number like this, you have a variable, then you are required to use the parentheses like that. It ends up looking like a function call, but it's not exactly a function call because this is assigning a new value to that sample. So it's more like an array access, I think. Anyway, now that I saved this, the effect is still the same. I am going to put this window away for a moment just so we can turn this off and on as I speak and see the effect that this has on my voice. You can see that the waveforms get a lot narrower when I enable the effect, which is what we want. Now, we need to create a slider so that the user can control this number. And we are going to start with a slider that is just a number between... We'll see. So we'll have a slider. It will be the first slider, and it will be called gain. And it's going to start with 1 because multiplying by 1 doesn't affect anything. So when you just start this effect, it will not change the volume. And then the range is going to be, it needs to start with 0 because I want to be able to just completely mute the channel. Because if I multiply by 0, then I am taking all the samples and saying that they are all 0, because multiplying by 0 ends up being 0. And then I have a choice here of how much I want to affect. So if I want the gain knob to only be able to turn down the volume, then this number should be 1, because multiplying by 1 will not change the wave. But if I want the user to be able to increase the gain using our knob, using our plugin, then I want to make this number bigger. And I guess that's what I want. I want the user to be able to at least increase the width of the wave in 50%. We'll see later how much this affects the loudness of the wave. And then the step, I'm going to leave it as 0.01, which is fine grain. You have a lot of options in here. And then the user is going to see this gain, this name gain, when they look at the plugin. So now that I save this and I look at the interface for my plugin, it has this gain knob. And of course, I also want to use this. So let me put this window over here. I also want to use this variable so that when the user slides, he slides this slider I just saved. So when I do this, you can see the waveform becoming smaller and smaller until it is completely empty, just 0. And also I can increase the gain, make the waveform even thicker, so even louder. Okay, so that is setting the gain in terms of a multiplication factor. We are multiplying the samples by this number. But that's usually not how you think of gain. You don't think of gain as a multiplication factor for the waveform. Instead, you think in terms of dB, which is the unit of measurement that is used in these meters, that is used when you change this. It's dB, you can see there. So anywhere, when you're working with audio, anywhere you're changing the gain or the volume of something, you think in terms of dB. So we need to be able to transform between this unit of measurement, which is amplitude multiplication factor, and dB. So we need to think about the relationship between the two, because they are units of measurement of more or less the same thing in the universe. They're just measuring the thing differently. Here we are talking about amplitude, which is the distance between this middle line and wherever you have your sample in the waveform. So this is in terms of amplitude, but we want to talk about in terms of dB. So let's understand how dB even works. So the idea is, it's like this, or at least that's my understanding, okay? I'm not a professional in the field, and I read a lot about this. This is what I got out of all my readings. The intuition may not be 100% accurate, but it works for me and it makes sense with the formulas. So take this chance, hear me out. So the idea is like this. You have some amplitude. For instance, in this case, you have gain, right? That you can think of this as the position, and I can zoom horizontally so we can actually see the waveform. You can think of this, so as all these squiggly lines are going up and down, you can think of this as the position of the speaker cone when you are producing or reproducing that sample. So it's like the speaker cone is going back and forth, and it's moving air, and that air is reaching your eardrums, and then you hear that as sound. But this line indicates the position of that speaker cone that actually moves. And if you have monitors or big speakers, you can feel the vibration of this line. So another way of interpreting this is as voltage. So when the signal is coming through the wires and going to the speakers, that signal is represented with different voltages. So you can think of this as voltages as well. But that's all in terms of what goes in the line, what goes in the cable that connects to the speaker. That's not exactly how we receive that sound wave, because we receive it through air. So the cone is moving, and that's what you hear. When you hear that air moving, it is in 2 dimensions. The speaker cone is 2 dimensions, right? You can think of the speaker cone as 2 dimensions. It's like a plane that is moving back and forth. So that is 2-dimensional. So what we want to do is, first of all, take this gain, which is like the energy that goes to the speakers, and you want to square it. Why square it? Because it's an area. It has 2 dimensions. It's as if you are changing the speaker cone in 2 dimensions, width and height. So you're taking that line that connects to the speaker and you're transforming that into a 2-dimensional space. So that's the beginning. What we are doing here is converting from amplitude to power, right? So we are going from voltage to pressure to power. That's the first part. But these numbers are super inconvenient to work with because they are so small. We can see here that the samples are like very, 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 very small numbers. You can think of the square of this is going to be super small. I'll add here a debug variable. And then when we look at debug, so we are squaring the gain, not the sample. So I'll square sample 0, just so you have a notion of how small the numbers are. We're talking about very small numbers here because we took a number between 0 and 1 and we squared it. So when you do that, you end up with a number that is even smaller. Okay, working with these numbers would be inconvenient, wouldn't it? If you wanted to say, I want to change my waveform or change the volume on this waveform, not by 6 dB, but by 0.000000213. That is inconvenient. So a solution for this is to take the log of this value, the log of this number. And we want to take the log in base 10. So we use this function. So now we are talking about numbers that are more reasonable, okay? So these numbers they make more sense. They are always negative because the most a sample can be is the number 1, right? That's the top of the scale here. And then when we square that, you end up with 1, and the log of 1 is 0, because 10 to the power 0 is equal to 1. So then this number here, the most it can be is 0. Otherwise, it will be negative because you are taking 10 and you are elevating 10 to some power that is negative to end up with a number that is so small between 0 and 1. Okay, so we are taking the log of that, and that is going to give you a notion of, there is a name for this. It's a bell. It's a unit of measurement. You can look up the Wikipedia article for this. It's a bell. I think it's named after Alexander Graham Bell, the inventor of the telephone. Anyway, this is a bell. But working with bells is uncommon. Most people don't work with bell. They work with decibel, which is to bells like millimeter is to meters, or microgram is to grams. It's just a multiplication factor, right? So the same way that you have 100 centimeters in 1 meter, you have 10 decibels in 1 bell. And that is the formula to convert between amplitude and decibels. And now we are looking at the samples in decibels. And these numbers are still very small. But yeah, so that is the formula to convert. They are small, but they are the kind of number that you would see in a digital audio workstation, right? They are the kinds of numbers that you would see when working with audio, like minus 60 is, for instance, the beginning of this scale over here. Okay, so that is the formula for converting between amplitude and dB. So I can call this dB, for instance, just to make it clear. But there is a trick. The trick here is this. When you are taking the square of a value and then taking the log of that, there is a log rule that allows you to simplify this calculation. And that's convenient. That's, in fact, very important because taking the square of a number is expensive, while doing things like multiplication is less expensive. So we would want to have a way to just not do this squaring. And there is a way to do this. The log law that we can use here is that when you are squaring and then taking the log, what you could do instead is multiply by 2 the result of the log. So these two are equivalent. Okay, so that's just another way of writing this formula. And of course, we can simplify this further by saying, 10 times 2, that's 20. So now you have the formula that you would see in many, many places, in many plugins, the formula that you would use to convert between amplitude and dB. Okay, there is one wrinkle here. If the sample is 0, the log of 0 is undefined. You would see that in some places like digital audio workstations as minus infinity. I think that in JS Effects, if you take the log of 0, that works, though it is undefined. It actually works because it just gives you some dummy answer like 0. And then when you multiply that by 20, you end up with 0. So you cannot trust this computation when you're taking the log of 0 or the log of negative numbers as well. So if your sample is going in the negative here, before we were squaring the value, right? So that would get rid of negative numbers because things like minus 0.5 times minus 0.5 or really 0.5 squared, that ends up being a positive value, this value. But now we are no longer taking the square, so I think we should take the absolute value of this, and then dB is now behaving correctly again, because I don't know if you noticed this before, but before I had this, we had 0 here in many cases, and that's because in that particular moment, the waveform was below the line, it was negative, and the log of negative numbers is also undefined, so we end up with 0, which is that dummy value that JS Effects gives us. But taking the absolute gives us back that behavior that we saw before when we were squaring. So now this is really equivalent to the thing we had before when we were squaring the sample. So that's how you convert between amplitude and dB. That's how you go from amplitude to dB. Let's take a look at how, so I'm just going to say amplitude. Just so you have this here on the screen. Now let's take a look at the opposite, which is going from dB. And how do you get to amplitude? Well, you just do the opposite, right? So first here, this 20 that is multiplying goes to the other side of the equal sign as division, right? And then this log, that's log base 10. So you just take 10 and you elevate everything by 10. And in this case, there is no need for absolute values here because this dB it's guaranteed to be a negative number, and we want it to be a negative number, so that's all fine. And here is the formula to go from dB to amplitude. So now you know, it's just the inverse. It's not that hard. It's just the inverse. What you do is when you are going from amplitude to dB, use this formula. When you're going from dB to amplitude, use this other formula. And that is what we want to do. In our plugin, we have a gain that currently is in terms of amplitude multiplication. It's a factor that multiplies the amplitude, but really what we wanted is to have this in terms of dB, because that's what we usually see in digital audio workstations, right? We want this to be in dB. So what we have to do is to use this second formula because we have dB and we want amplitude. We want the gain in amplitude. So I will rename this variable to be gain in dB. And then let's write some code that runs every time we change the slider. So every time we move this slider on the screen, this block of code is going to run. And what we do is then define a variable called gain in amplitude. And that is the thing that we are actually going to multiply the samples by. And then we use the formula 10 to the power of gain dB divided by 20. Save that. And now we should change the limit, right? So now we are working with dB. So by default, I don't want to change the gain. So when I load the plugin, I don't want to change the gain. So in terms of amplitude, that would be 1. But in terms of dB, that is 0. I don't want to make any change. And let's make sure that this works. So if gain dB is 0, then we have 0 divided by 20, which is 0, and then 10 to the power of 0, which is 1. And then gain amplitude is going to be the multiplication factor. So anything multiplied by 1 will be that thing. We won't change anything in the samples. So now we have the minimum value. This gain plugin will allow you to change at most 60 dB. So the most you can attenuate the signal is 60 dB. And that's just because I don't think there is any way for you to have minus infinity here. So this cannot go all the way. And then the maximum, I'm going to allow you to go at most, 12 dB. That's the most. Right? I'm not going to make these values as big as 60 because then you would be able to turn up the gain too much. It could be a problem. And then in terms of the steps, I'm going to just decrease this step. It's going to be 0.1. And now this is gain in dB. And we can move this slider. It's going to attenuate the signal. We can move the slider up. It's going to increase the signal as we can see here. I'll also put this screen over here and stop holding so that we can look at the waveform. So now the waveform is very thick. The waveform now is way, 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 way smaller. Almost as small as 0, though not really, right? Because we are only attenuating by 60 dB, not by minus infinity dB. Okay, so that is the code that we have to write to make the gain knob work. But there are a few other things that I want to cover before we say goodbye in this session. The first is I want to make sure that I got this formula exactly right. And I want to show you that we got this exactly right. So right now I have the microphone enabled and you can see roughly that it's roughly doing its job. But I want it to be super precise and show that it's working exactly right. So I'm going to turn off the microphone and bring in a tone generator. Because with the tone generator, I can very precisely say I want a noise that is exactly this dB loud. And this tone generator, we are going to create a tone generator in a future episode. You just saw me bringing the wrong tone generator. But this is the one that comes with Reaper. So now we are producing noise that is exactly minus 12 dB. And we have the gain here. So this comes in as exactly minus 12 dB. And if I bring it down 6 dB, actually I can type in if I want a precise value, so minus 6 dB, and we are reaching minus 18. That's good. What if I wanted to get to minus 30? So 30 minus 12, that's 18. So minus 18 dB, and we are getting to 30. I mean, it's not like rocket science here. We're not exactly on spot, but neither was this, right? So who knows? Maybe Reaper is not measuring the loudness correctly. Maybe this plugin is not generating exactly minus 12 as it's saying it should. Anyway, the point here is our plugin is doing what it's supposed to. Let's go to minus 54. So minus 54, we need to decrease this by minus 40. And yeah, it is not like 100% there, but it's almost. And what if we wanted this to be minus 6? Then we would have to increase this by 6. So if we put 6 here, yeah, it is right there. Okay, and we can see here the waveform changing as well. And if I zoom in the waveform, you'll be able to see that these are sine waves. They look like these squiggly things, and when I change the gain, it's changing how much the squiggly thing is going away from the middle line, but it's not changing how many of these peaks and valleys we have. It's just changing the perceived volume. It's not changing the pitch. And okay, so that is a way to see that we are there with the gain knob. It's doing the thing it's supposed to. I will again turn on the volume here, and I will record something real quick just because I want to show that it's not introducing any kind of distortion. And we already saw that with the waveform, the sine wave, but I want to make sure that we are not introducing any audible distortion. So I'm going to record a snippet. I already have this enabled for recording. So as I speak now, this is recording. And when I change the gain, you will be able to see the waveform changing here. But more importantly, you will be able to hear the difference in volume. So let's stop and move the cursor back to the beginning. And now, because we are fairly sure that this is the code that we want, that it's not introducing any weird loud noises, I am going to come back to the mixer, and I'm going to, first of all, I will stop. I don't want you to hear me twice. So now I will enable this, and we'll be able to hear this track as it's coming through, and I will be changing the knob. I will be listening to this as well. And we'll be able to determine whether this is introducing any distortion. Okay, let's hear this. Speak now. This is recording, and when I change the gain, you will be able to see the waveform changing here, but more importantly, you will be able to hear the... Okay, so it's not introducing any kind of distortion, but there are a few more things that I want to cover before we say goodbye. So when you're doing these kinds of computations with dB, so there are many cases in which you want to talk about dB, and you want to do computations with dB that are not as simple as just multiplying. And in many cases, you have a signal that is in terms of amplitude, but you want to talk about in terms of dB. So what you would have to do is go from dB, go from amplitude to dB, and then you would do some computation, and then you would transform back to amplitude, because that's what you need to output by the end of the day, right? So this conversion from amplitude to dB, and then from dB back to amplitude, can be avoided in some cases. And that is if you use the log loss, because that's the heart of the conversion, right? The heart of the conversion, the thing that really is doing the bulk of the work, is the log. The rest is just taking absolute values and multiplying. But this is the heart of the thing here, the log conversion. So if you want to do these computations that should be done in terms of dB, but you want to avoid the conversion back and forth, and in many cases you can do that, You just need to look up the log loss. For instance, suppose that you want to subtract two values in terms of dB. So suppose that you have, I don't know, some kind of signal and you want that to be in dB, and then you want to subtract by some constant in dB. Right? Another way of doing this is if you look at the log loss, if you think about this, this is really the log of some amplitude, so the log of some signal amplitude. And of course, it's not as simple as that. There is also the multiplication by 20 and taking the absolute value, but never mind that. The principle here is that you're taking the log of something and subtracting by the log of constant in amplitude. So that's the heart of what's going on here, the subtraction in log terms. Well, another way of doing this is if you look at the log loss is by using division, because subtraction in terms of logs corresponds to division in terms of not logs. I don't know how they are called, but the non-logarithm thing. So you can avoid the conversion from amplitude to dB and then back to amplitude in many cases if you just use the log rules, the log loss. And you can look at the rules online, and there is a bunch of them. There is a table. So multiplication, so addition corresponds to multiplication, and subtraction corresponds to division, as I just showed you, and so on. So I'm going to leave everything here in this file, all the comments. So when you look at this code, you can find the link to the code in the description below. There will be here the formulas, and that is handy. And before I go, there is just one final thing I want to mention. There is actually one extra term in this formula. There is actually one extra term here, and we are not showing it because it is irrelevant in this case, but it may be relevant when you are working with something else. So this absolute value is taking a number between -1 and 1 and turning it into a number between 0 and 1. So we are always talking about numbers between 0 and 1. But if you were to convert between amplitude and dB, and your amplitude is not represented with numbers between 0 and 1, but let's say the amplitude is represented with numbers between 0 and 100, you have to do something else here in this conversion. You have to divide by 100. You have to divide by your reference value. That is the range that you are working with, the maximum value for amplitude that you are allowing in this measurement. So in this case, in our case, we are talking about dividing by 1. So dividing by 1 doesn't have an effect. We are better off just not dividing by anything. But you need to be aware of this in case you are working with amplitude measured in some other way. So just something to keep in mind. So I'm going to leave here this, maybe in parentheses, divided by the reference, or really divided by the maximum amplitude. Just when you look at this file, you remember this part and say, yeah, my value is between 0 and 1. I don't need this part. But in other cases, maybe I would need that. Okay, that is it. That's all I have to say. We have a working gain plugin that is better than some other gain plugins because it works with multi-channels. We learned how to work with multi-channels, I think. I don't think we did this before. So that's another thing we learned. And also, we learned how to do this conversion, which is all over the place. You're going to find code like this everywhere. And we learned why and how this conversion works. That's all I have for today. Thank you very much for watching. If you're liking this kind of material, if you want to learn more about coding and about coding audio effects, which is a special kind of coding because it's in real time, it has to be super fast. And if you want to understand how plugins work, if you work with audio and you want to understand how a compressor works, how EQ works, how conversion between amplitude and dB works, then you should subscribe to this channel because I am putting out a lot of videos in which I'm live coding things, I'm explaining everything I'm learning because I am still learning about these things, and I want to share with you the things that I learn. Also, if you find these plugins useful, and every plugin we are doing is super simple, at least for now. They may not be as simple in the future, but they are all have something, just this small thing that is different. For instance, in this case, the multi-channel support. There is always one thing that is different, and it's actually a working plugin. You can use this. It's super fast too. Look at this. It's almost consuming no CPU at all. So these are usable plugins. And if you want to install them, or if you just want to have them convenient for you to play with, then all of them are available in Repack. You can find the link to install below, and in Reaper you have to install Repack, but then you come here to Repack, import that repository, and you will have all the effects we are writing in your Reaper installation as well. Okay, I'm going to leave it as this for now. Thank you very much for watching, and I see you on the next one. Bye.